Okay, welcome back. Exponents and radicals, lesson 7, rational exponents, part 2. This is our last formal lesson for this unit. Quick review of our product or of our exponent laws that we've looked at. Product law: x to the power of m times x to the power of n is equal to x to the power of m plus n. We add the exponents. Power of a power law: x to the power of m times to the power of n is x to the power of m times n. We multiply those exponents. Power of a quotient law: x over y all raised to the power of m is x to the power of m all over y to the power of m. So we're basically using our power to a power law here. There's ones here that we never write, okay? And remember, of course, y cannot be 0. When y is 0, then that's undefined. It doesn't work. Integral exponent law: x to the power of negative m becomes 1 over x to the power of positive m. Rational exponent laws: x to the power of m over n is equal to the nth root of x to the power of m, or the nth root of x all raised to the power of m, either or. Our quotient law: when we're dividing, x to the power of m divided by x to the n, x to the m minus n. And our last one, power over product law, is basically our power to a power rule, but we can apply this m to both the x and the y. So this becomes x to the m, y to the n. And again, you'd multiply those exponents together. There's a 1 here, never write it. Sometimes it's more than 1 and you would just multiply them. So if we look at some examples, write each power as a radical. Remember, the denominator of the fraction is our index, so this is the 6th root of x. And there would be a 1 maybe. I wouldn't write it, but you could put a 1 there. Right? We never write the 1, so it's not there. Negative y to the power of 5 over 4. Remember, that's not negative y in brackets, so that negative 1 stays out in front somewhere. And then this is going to be the 4th root of y to the 5th. Negative z is in brackets, so this is going to go with it. So it's going to be negative z something. It's going to be the cube root of all raised to the power of 5. Or you could put the 5 on the inside, your choice. In D, negative z to the negative 5 over 3. So that's our negative exponent rule right here, integral exponent rule. So because this is z over 1, I'm going to flip it. And the exponent on this becomes positive 5 over 3, which is 1 over the cube root of negative z in brackets, that's a z, all raised to the power of 5. 5t to the power of 3 over 4. Remember, that's 5 times that, so that stays out somewhere. It's going to be the 4th root of t cubed. That power does not apply to that 5. If it did, those would be in brackets, right? So be careful. Oh, just like f, that's in brackets. So this is the 4th root of 5t in brackets, and then cubed. Example 2. Simplify the following. Write each expression as a power with positive exponents, then as a radical. Power and a radical. X to the power of 3 over 2 times x, which is x to the power of 1. So really, I need to go, because it's the same base, I need to go 3 over 2 plus 1. Well, 3 over 2 plus 1 is 3 over 2 plus 2 over 2, because we have to have the same denominator, which is 5 over 2. So this is x to the power of 5 over 2. There's your exponent, but this is square root of x to the 5th. There's your radical. Y to the 1/3 divided by 5/3, which is y to the 1/3 minus 5/3. Well, 1/3 minus 5/3 is negative 4/3. So now we have y to the power of negative 4 over 3. Well, this is over 1, so I'm going to flip it. 1 over y to the power of 4 over 3. There's your exponent as your radical, square root of, or not square root, cube root of y to the 4th. Question C. A to the power of 1 over 2 to the power of 2 over 3. We're going to multiply these together. When we multiply fractions, it's straight across the top, straight across the bottom. So this is a to the power of 2 over 6, which reduces to a to the power of 1/3. There's your exponent. As your radical, it's the cube root of a. X squared over y, all raised to the -1/2. Well, that's a negative exponent, so I'm going to flip this fraction first. Y over x squared, all to the +1/2 now. Now that is the square root of y over x squared, which, because that's an x squared, I'm going to say square root of y over the square root of x squared, which is just x. Square root of y all over x would be the most simple form. Example 3. Simplify the following. Write each expression as a power with positive exponents and then as an entire radical. Does that say entire radical too? Well, it does say an entire radical. Well, as an entire radical, I probably should have stayed here. Hey, 4x to the power of 4/3 times 3x to the power of -1/2. Same base, so I'm going to add exponents, but I'm going to multiply these coefficients together. 12x to the power of 1 over 3 over 4 plus -1 over 2, which is 3 over 4 plus -2 over 4, which is 1 over 4. 1 over 4. So this is going to be 12, the 4th root of x. And that's the most simplified form of that. So I would actually leave that right there. Question B, 5x to the power of 3 over 5 divided by 25x to the power of -3 over 5. So I'm going to simplify my coefficients. 5 divided by 25 is 1 over 5. And then I have x to the power of 3 over 5 minus a -3 over 5. Because when we have the same base, we're dividing, we subtract. Whoops. Okay, same base, we're dividing, we subtract. Minus a minus is a plus, so this is 6 over 5. 6 over 5. And then as a radical, 1 over 5, 5th root of x to the power of 6. Question C. 8 to the power of 1/2, 8 times a to the power of 1/2, all raised to the power of 4 over 3. Remember, there's a power here, we never write it. I'm going to multiply this here, and multiply this here. 8 to the power of 4 over 3, a to the power of 4 over 6. 4 over 6. 4 times 1 is 4, 2 times 3 is 6. Beautiful. 8 to the power of 4 over 3 is the cube root of 8 all to the 4th. I'll continue with this. Cube root of 8 is 2 to the 4th. 2 to the 4th is 16. A to the power of 4 over 6 is a to the power of 2 over 3, which is the cube root of a squared. Okay, let's look over the page. Well, we've looked at this rule before, so now we're going to play with that a little bit, I guess, with example number 4. Write each radical as a power in the form of a to the power of n. So now we're working this backwards. A to the power of, the cube root of a to the power of 5. Well, a is still our base, 5 is our exponent, and our denominator of our fraction is our index, a to the power of 5 over 3. B, this would be a to the power of 2 over 5. Exponent, denominator. A to the power of 9 would be a to the power of 9 all over 2. So remember, there's a 2 there. We never write it. So only C, or is there a D? There's a D. A to the power of 1 over the square root of a to the power of 7, which is going to be 1 over the power of a to the power of 7 all over 2. There's a 2 there, right? And I think that's where I would leave that question. That's a positive exponent. I wouldn't rearrange that any further, okay? Because it's always, we haven't talked about it yet, but final answers cannot have negative exponents. Okay? We did talk about that last year, but final answers cannot have negative exponents. Okay, we're down to our last couple of examples here. Example 5, write as a power and evaluate. Well, square root as a power is 1/2. So this is 1296 to the power of 1/2, all raised to the power of 1/2, which is 1296 to the power of 1 over 4. So the fourth root of 1296 is equal to 6. Square root of 1 over the square root of 169. Okay. Right as a power, which is 1 over 169 to the 1/2, which is equal to 1 over 13. Question C. Cube root of the square root of 64. Well, 64, square root of 64 is to the 1/2, and cube root is to the 1/3. So this is 64 to the power of 1 over 2 times 1 over 3, which is 1 over 6. 64, sorry. Let's erase that. That got messy. 64 to the 1 over 6. 6. Be a 6. Come on. Just want a 6. There. And 64 to the 1 over 6 is 2. Question 6. Last 6 examples. Write each expression in the form of ax to the n, where a is an integer and n is a rational number. Well, cube root of 8x to the 5th is going to be 8x to the 5th, all raised to the 1/3. When I multiply this in, that's going to be 8 to the 1/3 times x to the power of 5 over 3. 8 to the 1/3 is 2, so this is going to be 2x to the power of 5 over 3. Question B. 5th root of 32x cubed. Well, it's 32x cubed, all raised to the power of 1/5. 30 is, I'm going to multiply this in. 32 to the 1/5, x to the 3 over 5. Well, the 5th root of 32, which is 32 to the 1/5, is 2. 2x 3 over 5. Question C. 900x. Square root of 900x. Okay. Another way you can look at doing some of these is I could split this up. Square root of 900 times the square root of x. Well, square root of 900 is 30. Square root of x as an exponent is x to the power of 1 over 2. And that one's done. Sometimes it helps to split them, sometimes it helps to not. Cube root of x to the 5th times the cube root of x. A couple of ways you could actually tackle this question. One, because they're the same root, they're cube roots, it's the same as the cube root of x to the 5th times x, which is the cube root of x to the 6th which is x squared. Or I could say, well, the cube root of x to the 5th is x to the 5 over 3. The cube root of x is x to the 1 over 3. When I combine those using my rules, it's x to the 5 over 3 plus 1 over 3, which is x to the power of 6 over 3, and 6 divided by 3 is 2. You can get to the same place. I can only do that, though, because those indices, the index of the roots, are the same. You just have to be, I can only do this part because they're the same. This I have to do if they're not, for sure, like in question E. 2 times the square root of x times the cube root of x, which is 2x to the power of 1 over 2 times x to the power of 1 over 3. Same base, I add the exponents. 2x to the power of 1 over 2 plus 1 over 3. Common denominators because we're adding. This is going to be 3 over 6 plus 2 over 6, which is 5 over 6. 5 over 6. And you're done. And that brings us to the end of the exponents and radicals unit. Test will be coming soon, review package soon, and check Scholastic to see what questions you need to be working on. Until next time, we'll see you then.